All right, this is going to be the video for indicator 4.1 on the final exam review. Lots of simplification. So I'm going to jump right into question number 1 here. And we have basically a whole bunch of exponent rules going on. We're going to start with the numerator, which is an expression raised to the second power. So we're going to do 4 squared, that's 16. X to the negative 3 squared, which is x to the negative 6. You multiply the exponents. And then y to the first squared, so y squared. That's going to be 8, x to the 11th, y to the negative 6th. The deal is, these pieces, and only these pieces that have the negative exponents, need to move. So 16, I'm going to leave the y squared where it's at. I'm going to write the x to the 12th in the denominator. Now, this x to the 6th is going to move to the denominator, and it becomes positive. And then this y to the negative 6 is going to move up to the numerator, and it becomes positive. So we're going to simplify here. 16 over 8, that simplifies to just 2. All of the y's are up in the numerator, and that's a total of 8 of them. All of the x's are in the denominator, and that's a total of 18 of them. All right, so that's the simplified version for question number 1 there. Problem number 2, you need a common denominator. And the common denominator here is going to be, let's see, 3 and 4 is a common denominator 12, y squared, and x. Now, the order you write that doesn't particularly matter. So if you did 12xy squared, same thing. What I need to look for then is how to get from this current denominator to this one, and how to get from this current denominator to that one. So to get from 3 to 12, you're going to multiply by 4, and you don't have an x. So you got to do that to the same top. Do that to the top as well. So that's going to turn into 4x to the 8th. All right, and then we're going to add. Let's go ahead and do the same thing here. How do you get from 4x to 12y squared x? Well, you multiply by 3y squared. So times 3y squared. So that's going to be 2 times 3 is 6 py squared. None of this is like, well, actually, I lied. There is one thing you can do to simplify. And it's not, these aren't like terms, but what I did notice, and it took me a second to find it, 4x to the 8th here, 6py squared here, and 12y squared x. All of the numbers can be divided by 2. So you can go ahead and divide that out. So that's going to be 2x to the 8th plus 3py squared all over 6y squared x. So that's the final simplified version. Okay. Question number 3, we're dealing with some fractional exponents. So 27 to the 2/3 is the cube root of 27 squared. 4 to the 3/2, that's going to be the square root of 4 cubed. All right, so quick reminder if you need it, that top number is your power, and this bottom number is your index. And the index is what root you are dealing with. All right, so let's see. The cube root of 27 is 3. 3 squared makes 9. The square root of 4 is 2. 2 cubed makes 8. Let's see. 9 plus 8 makes 17. All right, rolling right along. Now, this time we're dealing with negative exponents. And negative exponents, we kind of saw that in the very first question. We're going to create fractions here. This is going to be 1 over 4 squared, and this is going to be 1 over 2 cubed. Let's see, 1 over 4 squared, that's going to be 1 over 16. 1 over 2 cubed, that's 1 over 8. Need a common denominator here. The common denominator would be a lovely 16. Now, that first fraction isn't going to change. To get from 8 to 16, you're going to multiply by 2. And then you add them up, so there's going to be 3 over 16. All right, when you add, you have to have common denominators to add fractions or subtract fractions. But then when you actually do add or subtract them, the common denominator stays the common denominator. All right, we've got some radicals to simplify. So off to the side here, let's break up a root 12 here. Let's go 2 and 6, 2 and 3. So for the square root of 12, we got 2 times 2 times 3. So I'm going to keep this 3. And actually, I'm going to kind of color code this. So it's going to be 3 times. Now this simplifies to 2 root 3, right? You've got a pair of 2's here that escapes the radical, and then 3 stays underneath. All right, and then I'm going to do the square root of 27. We'll do 9 times 3, 3 times 3, so lots of 3's here. So 3 times 3 times 3. And again, we're going to keep the plus, we're going to keep the 2. The square root of 27 here, you got a pair of 3's. So it's going to be times 3 root 3. And then minus 5 root 3. Let's multiply what we can. So 3 times 2 here and 2 times 3 here. So 6 root 3 plus 6 root 3 minus 5 root 3. 6 plus 6 makes 12 root 3. Minus 5 root 3, 7 root 3. That sounds good. Oops. Oh, wasn't trying to throw that. I was trying to throw that. All right. So let's see what's next. Number 6. Simplify. Your job is to see if you can factor and cancel. So to factor the numerator, we're going to split the x. I need to think of numbers that multiply to negative 12 and add up to negative 1. So we're going to go 4 and 3. That's a horrible plus sign. Let's try that again. Denominator, I'm looking to do a difference of perfect squares. So x and x. Let's go ahead and split the 9. 3 and 3. We're going to make one positive, make one negative. The positive 3 here, x plus 3, and the x plus 3 here completely cancel each other out, divide each other out. So x minus 4 in the numerator and x minus 3 in the denominator are left. All right, we're going to keep on going to simplify here. Love the order of operations. So let's do what we can for things that do not affect each other. In the parentheses, 3 minus 5 is negative 2. I'd recommend keeping the parentheses to remind yourself to multiply. Plus 5 to the 0 is 1, and then negative 3 cubed is negative 27. Not a huge fan of the double negative, but I'll fix that on the next line. So negative 2 times 5 is going to be negative 10, and then minus 27. Let's see, lots of negatives here, so that's going to be negative 12. 27, so negative 11 minus 27. These are both negatives, so we're just going to make a bigger negative. That's going to be what, negative 38? Yeah, that sounds good. All right, number 8 here, we're going to simplify a cube root. I'll deal with the variables in a minute. I'm going to go off to the side here, remind myself for a cube root of 8, how I can break that up. So 2 and 2. So 2 by 2 by 2. And because we're talking about a cube root, I am looking for sets of 3, and I have one set of 3 here. So the cube root of 8 is just 2. And there's a couple of different ways you can do this. If you want to, you are welcome, and I'll slide this 2 down a bit. You are welcome to write out all of the x's that you have, right? 1, 2, 3, 4, 5 of them. And your index number tells you how big of a group you're looking for. So we are looking for a group of 3. So there's a group of 3. And that means one of your x's gets to escape the root. But unfortunately, under that cube root, you'd still have an x squared because there's 2 x's that did not group up. The alternative to that is you can actually just ask yourself, take your index number and try and divide it into your power. Now, y to the 6 is going to divide very nicely. So 3 goes into 6 2 times. Nothing's left over. And I did realize I'm going to slide this over just a touch. So there's a little bit of extra space here. Oops, hold on. There we go. Between where the y squared is and my cube root is. All right, but that is the final answer for number 8. And then I think this is the last one, number 9. We've got a couple of power rules and some product rules to deal with. So 3 squared makes 9, x to the negative 4 squared would be x to the negative 8th, and y to the first squared is y squared times. Times, people, times. There's no plus sign in this problem, so we can't add 1. Literally add 1. 2 cubed makes 8. X to the 7th cubed is x to the 21st, and then y squared cubed is going to be y to the 6th. We are going to multiply what we can, And then we get to our variables, we're going to apply the product rule, which says if you're multiplying like bases, you get to add the exponents. All right, let's start with the 9 times 8. That's going to be 72. We've got x to the negative 8th times x to the positive 21st. That's going to be x to the, what do I want that to be, 13th? 13 and 8, 7. Yeah, that makes 21. All right. And then y to the 2 and 6 is 8. All right, lost a little box there. All right, so that's all the little bits, parts, and pieces for indicator 4.1. Of course, I will keep making more videos. And if you have any questions or concerns, please let me know.